Hello everyone, welcome back. Today we are learning units in physics, so let's get started. Contents. What are units? What measurement of physical quantity? Co- system of units and fundamental units, supplementary units, derived units, rules for writing units in SI system, multiplies and multiples and submultiples. What are units? A unit of a measurement is a definite magnitude. So let's underline this. Or a definite, so it's not unlimited. So I have 1 meter of clothes. So I get 1 meter itself, 1 m. So it's a definite magnitude, right, of a quality defined and adopted by convention or by a law that is used as a standard measurement. So we use meter like everywhere, so it's a standard measurement of the same kind of quantity. So we can convert this. Any other quantity of that kind can be expressed as a multiple of the unit. So 1,000 meter equals 1 kilometer. So that's multiple, and I'll explain you that later. Measurement of physical quantity. Physical quantity is a property of an object that can be quantified. So he's telling how big is that cable, he's wondering. So they gave the measurement of it, but they didn't give the definite measurement. So we need to measure that, but so we can we can find out, right, how much is it. So how do we measure it? We measure it meters or it is a small, we measure it with centimeters. If it is big, we measure with kilometers. So that is what. For instance, the physical quantity are the length of a rod or the mass of a body. Measurement is the act of comparing a physical quantity with its unit. Measurement results is the value of a physical quantity obtained by means of measurement. The system of units. The international system of units called SI. So system of units, so SI, abbreviated from the French system international. D units is the modern form of metric system. It is the only system of measurement that with an official status in near life. So this SI unit can be used anywhere, not only in like USA, UK, sorry guys, UK. It can be used everywhere. So that is what they're telling. And these are the few of those. You could read them. Let's go to the next page. Fundamental units. Units of fundamental physical quantities are called fundamental units. In SI system, fundamental quantities are 7 and the fundamental units are as follows. So you guys can see these are the units of fundamental units. Supplementary units. Units of supplementary physical quantities are called supplementary units. In SI system, supplementary physical quantities are 2 and supplementary units are as follow. So here we go. You could see plane angle, radian, solid angle, star radians. The symbol also they gave rad and SR. Derived units. Units of derived physical quantities are called derived units. SI system. SI units of some derived quantities are as follows. You could read them. Rules for writing units in SI system. Symbols used for units are always written in small letters other than the names of scientists. So I'm writing meter. So why do I only write it? Because it's in a not in caps. Because it's not the name of a scientist. Symbols for a unit named after scientists is always written with a capital letter. So 1 Kelvin. So Kelvin. And I should write K because it is a name of a scientist. So a unit should be represented in a singular form. So I'll write 1 kg, not 1 kgs. That's the difference. So why? Because if we just remove and put 2 here, it's 2 kgs, so it won't be 2 kgs. So that's the difference. A unit punctuation like full stop, comma, etc. should not be used after a symbol of a unit. So I will write down 1 SR full stop. That's wrong because 1 SR, that's it. We don't have to write a full stop there, also it's wrong. If we are writing the full form of a unit, we start with the small letters. So I'm writing Kelvin, okay? Many people don't know this, so you people will write because you people might think that Kelvin is the correct because you told to write capital K, so we are writing capital K. But for the full form, you should not write. You should write the small k because that's the law. That's the rule. That's another rule. Negative powers are compound units formed by dividing one unit by the other. So you can see it. Meter per second. So the per comes by the division. So let's go next picture. Multiples and submultiples. Need of multiples. To measure the distance between two far off cities, say Delhi to Mumbai, measuring in meters is not only difficult but very inconvenient too. Hence we use another multiple units. Say kilometer is a multiple of the meter. Okay, so I'll give you this example. So this is city A and this is city B. The space between them is 110,000 meters. So we can write the M over here and then so after we write the M, we can convert this into kilometers. So it's just going to be 10 kilometers. 10 km. So that's more easier than writing everywhere 10,000 meters. So the easier form is we can convert it into multiples. Units which are used to measure large quantities are called multiple units. I gave you an example, right? City A to city B. Need of submultiples. Some lengths are much smaller than meter. For example, the length of an eraser or a pen or say our nails. We again cannot depend on the meter, but we need some smaller units like centimeter, millimeter. So I have a small pencil that is 0.010 meter. Should I write it like that? No, that's very uncomfortable. We need to write everywhere such a big. So instead of that, we can just write 1 mm. That is called millimeter. So that is a submultiple. 1 centimeter stands for 1 by 100 or 0.01 or 10 to the power minus 2 and represented with the letter C. Small c, I mean this one. Units which are used to measure smaller quantities are called submultiples. So this is the chart of multiples and submultiples. So this is the chart of multiples and this is the chart of submultiples. The names and the examples are given. You could pause the video and read them. Bye guys, thank you for watching. See you at the next video. Bye.